Welcome to lesson 5.5, use inequalities in a triangle. So obviously we are looking at that idea of inequalities in this lesson, meaning, remember, an inequality is less than, greater than, less than or equal to, or greater than or equal to. So no longer just the equal sign, we're dealing with our inequality symbols. Now, in triangles, there's a couple theorems to help us understand the rules of inequalities. So the first theorem is 5.10, and it says if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So looking at this example, segment AB is longer than BC, which would mean the angle opposite AB, angle C, is greater than the angle opposite BC, which would be A. Then theorem 5.11 says if one angle of a triangle is larger than another angle, then the side opposite the larger angle is the longer side compared to that side opposite the smaller angle. So if we look at our triangle down here, angle A is 50, angle C is 30. So the side opposite the 50 degrees would be longer. So side BC would be longer than side AB, or greater than. So our notation right there. So these two theorems are what we're going to look at here in example 1. So example 1 is a word scenario, and it says you are constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is about 27 feet long. The left slope is about 24 feet long, and the right slope is about 20 feet long. You are told that one of the angles is 46 and another is about 59 degrees. What's the angle measure of the peak of the mountain? So we need to first draw ourselves a triangle and use our theorems 5.1 and 5.11 to fill in what we know. So I just drew myself a triangle with 3 different side lengths. The bottom is 27, that left slope was 24, and that right slope was 20. Then what I knew are 2 of the angles are 46 and 59. We need to figure out the measure of the peak. Well, all triangles have a total of 180 degrees for their 3 interior angles. So if I do 180 minus the 46 and 59 that we already knew, that leaves me with the third angle being 75 degrees. Now I need to figure out which one's the 46, the 59, and the 75. To do that, I'm going to base it on the side lengths. Our shortest side is 20, so the angle opposite that has to be the smallest, which was 46. Our middle side is 24, so the angle in the middle, 59, would be opposite that. 27 on bottom is our longest side, which means the biggest angle is opposite that. So our peak angle was 75 degrees. In example 2, it says list the sides of triangle RST in order from shortest to longest. So they gave us 3 angle measures. We just need to list the sides in length, shortest to longest. So angle R is my smallest angle at 29 degrees. So the side opposite that, ST, is my smallest side. So our smallest side is segment ST. Then opposite 30 would be next, which was segment RS. And then opposite the 121, which was segment RT. Then we have theorem 5.12, which is one of our most important theorems as far as triangles go. And this is our triangle inequality theorem. And that simply states the sum, so addition, answer to addition is sum, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So any two sides added together have to be longer than the third side for it to be a triangle. So looking at this example, AB plus BC would have to be bigger than side AC. Side AC plus side BC is bigger than side AB, and AB plus AC is greater than side BC. So any two sides added must be longer than the third. If that's not the case, we do not have a triangle. So example 3, doing the algebra based around that theorem. So it says a triangle has one side length of 12 and another side length of 8. Describe the possible lengths of the third side. So possible lengths mean, depending how we draw this triangle, we could have some smaller values or larger values. And what I mean by that is, if we think about the small values, we could have a triangle like this, where 8 plus x has to be greater than 12. Any two sides have to be greater than the third. So x plus 8 is greater than 12. Subtract 8 from each side, and x has to be greater than 4. Then we also could draw the triangle looking at the larger values for x, where we have the 8 and the 12 added together to be greater than our missing side. So in that case, 8 plus 12 is 20, so 20 is greater than x. So what that tells us is the third side of our triangle, x, is greater than 4 and less than 20. So our third side length is anything greater than 4 and less than 20 would work to create a triangle with a side of 12, 8, and then this unknown side. Example 4 is asking, is it possible to construct triangles with the given side lengths? If not, explain why. So remember, any two sides have to be greater than the third. So if I take the 3 plus the 6, is that greater than 9? 3 plus 6 equals 9, so it's not greater than. So I don't need to try any other combinations. I know, in this case, two sides added together are not greater than the third, so it's not a triangle. In B, 35 plus 120 is greater than 125. 125 plus the 35 is greater than 120, and 120 plus 125 is greater than 35. So in this case, any two sides added is greater than the third, meaning yes, this triangle is possible.